students, so here we are with the question second of the exercise 4.1 for the chapter Quadratic Equations. So the question second is represent the following situations in the form of quadratic equation. And the first problem is the area of the rectangular plot is 528 meters square. The length of the plot in meters. Just remember the units of the length and the breadth of this particular rectangular plot is meters. And what it's been given, the length of the plot is 1 more than twice its breadth. We need to find the length and the breadth of the plot. So in order to solve this problem, that is in order to represent this English form into the mathematical form of this problem, what I need to do, I'll let breadth of rectangle, or I can say rectangular plot, is x meter. And also it's been given in the question that the length of the plot is 1 more than twice its breadth. So length of rectangle will be 2x, that is twice its breadth, plus 1, that is 1 more than twice its breadth. So this will be the length of this rectangular plot. And also it's been given that the area of rectangular plot is 528 meters square. Means we know that length into breadth is equals to the area of rectangle. So it's been given that area is equals to 528, means we will be multiplying x into 2x plus 1, which will be equal to 528 meters square. So here it will be 2x plus 1 into x is equals to 528. Right. So here I'll be getting 2x square plus x is equals to 528. Now taking the right hand side term to the left hand side, I'll be getting 2x square plus x minus 528 is equals to 0. Means I have represented this problem into the form of quadratic equation. As it's been clear that in this equation, the highest power of the x is 2 and its coefficient is not equal to 0. So means this equation is perfectly the quadratic equation. So now what the next step is to find the length and the breadth of the plot. Means the first step I need to do is to find the value for the variable x. And as we know, the only method to solve the quadratic equation is middle term splitting. That is, the middle term has to be split into two terms such that their product is equal to the product of first and the last term of the quadratic equation, and its sum is equal to that of the middle term. So in order to split the middle term, what I'll be doing, I'll be multiplying 2 into 528, which comes out to be equal to 1056, and will find the factors of 1056. So performing the prime factorization for the number 1056, here it will be 2, then it will be 528, and again 2, which is 264, 132, then again 2, then here it will be 66, then again 2, here it will be 33, then 3, and then 11. So for these prime factors of the number 1056, I need to form two terms such that their sum comes out to be equal to plus x, or I can say 1, that is coefficient of the middle term. So the two terms I'll be writing here will be 2x square plus 33x minus 32x minus 528 is equals to 0. So if I say the first and the second term, I can take x common. So here I'll be left with 2x plus 33. And from third and the fourth term, I'll be taking minus 16 common. In the bracket, I'll be left with 2x plus 33. So I can express the left hand side also in the form 2x plus 33 into x minus 16, which is equals to 0. So from here I get two factors for the x, or I can say two values for the x variable, which are 16 comma minus 33 by 2. How these values have been obtained? By equating each term individually equal to 0. That is, first I have equated 2x plus 33 is equals to 0, and then I have equated x minus 16 equals to 0. So as we know, the length or the breadth cannot be negative value, which is practical case, as practically we cannot get the length or the breadth value to be negative. So the only valid value for the x will be 16. Means x has the value 16, and as I have assumed that x is breadth of the rectangle. So from here, breadth of rectangle comes out to be equal to 16 meter, right? And also I have assumed that the length will be equal to 2x plus 1. So substituting the value of x in 2x plus 1, here I'll be getting 33 meter. So I have obtained the value for the breadth as well as for the length of the rectangular plot, which are 16 and 33 meters respectively. So this was about the first problem of question second of exercise 4.1.